Our first part here is we are on 11.6, properties of chords, and your objective that is at the top of your page is to use properties of chords in a circle. Your first question here is what you were working on is if an arc of a circle is 100 degrees, what is the inscribed angle? This was yesterday's lesson. So how are those two related? So you take the 100 divided by 2, so remember that's the intercepted arc, half of it is the inscribed angle, and so that is going to be 50 degrees. Nice job. Over here we have what is the radius, or if the radius of the circle. What'd you say, hon? Okay, let's talk about that later. So if the radius of the circle is 5 inches and the shaded area of the pie is 60 degrees, what is the arc length? Do you guys remember the arc length formula? So let's go through the formula first because I don't know what it is off the top of my head. So we start with our degrees of our shaded area of the sector, so that's 60. We put it over our total, which is 360. We multiply it by our circumference, 2 pi, and what's my r? 5. Okay, so now you're seeing that might not have been the best. So 60 goes into 60 one time. 60 goes into 360 how many times? 6. Then we see that 2 goes into 6 3 times, and 2 goes into 2 1 time. So 1 times 5 is 5. So we have 5 pi over 3 inches. What did you get for that? When you do this, you put it in your calculator? 5.24. Thank you. Inches. Okay, so this theorem says if two chords intersect inside a circle, remember chords have the endpoints on the circles or segments with that. So the measure of each angle formed is 1/2 the sum of the measure of the intercepted arcs by the angle and the vertical angle. So what you see here is that you have the measure of angle 1 is going to be the arc AB plus arc DC. Add them together and then divide by 1/2. Measure of angle 2 is going to be the arc AD plus the arc BC. You add them together and divide by 2.
If the vertex is on the circle, half the arc. If the vertex on the circle, half the sum. But if the vertex is outside, then you're in for a ride because it's half of the difference anyway. Oh, I killed that!
So our first one here is just like those first formulas where you take your arc, add the one arc, add the arc directly across from it, then divide it by 2. So you have x equals 1/2 of 60 plus 170. Well, 60 plus 170 right here equals how much? 230. We multiply that by 1/2, which is the same thing as dividing it by 2, which gives me what value? X equals 115 degrees. Nice job. Our second one over here is the same formula, but now you're looking for a different part. It gives you the angle, but now you're looking for the other arc. So we set it up, and then we have to solve backwards. So what you have is you have 68 degrees equals 1/2 of 38 degrees plus x degrees. You have two options at this point. You can either multiply by 2, or you can distribute the 1/2. Which one do you prefer? Well, I heard two things. I'm going to go with the first one. Multiplying by 1/2. Or no, you're multiplying by 2. So multiply each side by 2. What is 2 times 68? 136 equals, and then you're left over here. Ooh, these cancel. So you're left to just 38 degrees plus x. We got to get x by itself. How do I do it? Subtract 38 over, yep. And you're left with? 98. Hey, but you gave an answer, and I appreciate that. Okay, so on our previous one, we tried to find one of these two angles. Remember, these are vertical angles, which means the angles are congruent. But now we have this information, but we're looking for this angle. How do you think we're going to solve for that? I'm sorry, say it again. We're going to add them together, and we're going to subtract them by 360. So you take 360, and you're going to subtract 80, and you're going to subtract 72. And that gives you the arc measure of this part and this part added together. part added together. When you get that, what value do you get? 208. So now that we have that sum, that we just can do 1/2 of 208, which gives me 104 degrees. So we're back to that original setup. That angle is x equals 1/2 our two arc lengths, which is 63 plus 99. What is 63 plus 99? I got like 4 different answers. 162. So 162 times 1/2. Half of 16 is 8. Half of 2 is 1. X equals 81 degrees. So how do we solve this one? 360 minus. Yep, which gives you? What did you say? Yes. How much? 186. So that gives us 186. Now that we have that 186, we're going to multiply it by 1/2, which is the same thing as dividing by 2. What do you get when you do that? 93 degrees. Okay, our other one over here. It's going backwards. Yes, ma'am? You have to find your x. So it's our other arc. You have 74 equals 1/2 of x plus 124. What'd you do with that 1/2? So did you multiply by 2 or divide or distribute it out? So she said she multiplied by 2 on each side. So 2 times 74 is? Which equals x plus 124. You subtract 124 to the other side. And you get what value? 24. So this theorem says if two chords intersect inside a circle, then the product of the length of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So do you guys remember what it means to be a product? Yep, it means you're multiplying. So what happens here is you see that this segment here, CE, is multiplied by ED, and AE is multiplied by EB. We can set them equal to each other. So our first one here is you multiply the segments that are on the same line. So 12 times x gives me 12x. Over here you have 6 times 14, which gives you 6 times 14. What is 6 times 14? 84? So our next step is we're dividing by 12. When we divide x or 84 by 12, what do you get? 7. Over here, you're doing the same thing. 16 times x. So those are the segments that are on the same chord. Equals 8 times 10. We know 8 times 10 is 80. And then we have 16x. How do we get x by itself? Yep, we're going to divide each side by 16. What is x? 5. X equals 5.